Good morning and welcome to our today's class. In today's class, you're going to extend the use of the solver, that is in Excel, and also you're going to introduce yourself to how we can employ the use of developer to make our work easier. We're looking at profit efficiency using the data environment analysis to compute the profit efficiency. So we'll be using the environment form. And what is profit efficiency? If you see from the cursor, uh, sorry, if you see from the cursor, you would see that profit efficiency is a ratio. It's a ratio between the actual output and the expected maximum uh, profit that we can achieve. And this profit is difference between the total revenue and the total cost. For now, we know the prices of the output and the price of input. What we're looking to is the optimal output and optimal input that we can use and we can achieve. To start it off, we're working on a scenario where we've 7 farms, A, B, C, D, up to F, with a reference to farm 1, 2, 3, 4, 5, farm E as a decision-making unit. And we are looking to see that what is the maximum profit and which could be the most efficient farm with reference to farm E. So to start it off, we start with now setting the formula for now achieving this maximum profit. And we're going to index. What we are indexing here is the price of the output. You put a comma. We need to reference here the individual farm. There are so many farms, so we have to reference the particular farm that we're working with. Then we multiply with the optimal output. Then remember it's the difference between the revenue and the total cost. So we subtract, we index again. This time we pick their 2 inputs. We reference to the individual decision-making unit. And we multiply with second input, optimal input that we may use. Then we index again. This time around we pick the second input with reference to the given decision-making unit. We multiply with the optimal input of the second input. So with that one, we can put the brackets because we want to see the difference between the two. We put the revenue in the parentheses and also the inputs. Why are we adding? Because we have 2 inputs. If we had 3, we could still continue adding. If we had more than 1 output, we could still continue adding. But now we have 4 inputs and we enter. I don't know why it's not picking. Yeah, I think it's set. Right. It's set. Right. So the second aspect we now look at, these are the optimal. You're going to compute the value of lambdas, output and input as highlighted here. We can highlight them. The first output, the first optimal output, second, and the maximum profit. So in here, you also need to get the sum product. Uh, the sum product we're getting, we are going to get the value of the given output, then with the value of the given lambda into bracket. The second one, we're going to get the value of the given input, sum product, pick the value of the first input into bracket times the lambda, then we sum them up. Then the second sum product of the third input, comma, and we're going to go. We can try and highlight and see. Well, it's true. We can also try this one and see. Right, it's true. It's true. It's true. Yeah. So the other aspect we're going to do is it's here. We want to really put ensure that you've put. Remember the reason why if this equality sign. Our actual goal is to make sure that we don't condense the output, but we condense the input. That's why you have less than this one. So now the value that you are getting should be less or equal to. In here, we're going to index the output with reference to the given. We are saying that value should be not less. Let's put a value here. Yeah. So the other thing should be like we index till the input, because we are saying whatever we're going to get should be not more than the given level of the input. And the other thing we still index the second input. In indexing, we are basically saying that you want to have that value of the output and also ensure that it matches the given level of the decision making unit. In here, we just need to put an equal sign and ensure whatever value it's there, it's also here. Whatever value is there, an equal sign, whatever value is there, it's also equal there. Remember, we are saying we are using VRS, actually we have variable return to scale. We ensure that the summation of the lambda should be equal to 1. So we are saying the sum the lambdas and ensure that the summation of the lambdas, saying it's equal to 1. And with that one, we've set our uh, compare our sheets, and we are now ready to employ the use of the solver to get the actually to have the maximum profit and other optimal input and outputs. Now we go straight to the solver. We go to the data, the solver. In the solver, we're going to pick the objective function. Then we go to it, we are maximizing. Then the changing values should be a lambda and also this optimal input and output, right? Then we need to add, and when we add, we're going to pick this value, which we're saying should be greater or equal to this optimal value. Then we add, we pick the 2, which we're saying should be less or equal to the other 2. Then we add, we say this one, it equal to this one. Then we add this one is greater or equal to this one. Ensure they are 5. Then the last two, which are the same. And by doing this, actually, I'm saying that we already know how to use the solver. If you don't, you can visit the previous class. There are 5, 1, 2, 3, 4, 5. Then we ensure this one is simplex LP. And then let's try to solve and see here. It's accepted to give us the given value. So we are saying for the decision making unit 1, the maximum profit is 91, right? So it's having done that one, it's so very hard to really compute each and every one of them. So kindly join me in the next class. Okay, before we go to the next class, you can try and run the second one and see what will happen. We see what will change. It's not changing. I don't know why. Let's look at the seventh one and try to use the solver. Solve, and it's changing. The seventh one is 59. So we realize the maximum profits are basically 59. So it's so tedious to keep on changing the first one. You change the second one, the third one. There is a way we can employ the use of a developer and actually amalgamate in the process and get them as a whole. So kindly join me in the next class. For now, it's a bye-bye. See you until we meet in the next class.